example here is H, C, and N. H is the hydrogen, C is the carbon, N is the nitrogen. Let us now write their valence electrons. The valence electrons of hydrogen is 1. The valence electrons of carbon is 4, while the valence electrons of nitrogen is 5. Let's add all their valence electrons, and the total of their valence electrons is 10. Let us now move on to LDS, or should I say Lewis dot structure. In Lewis dot structure, we must apply the octet rule. Octet or octave is simply 8, so the elements should be balanced and octet. The valence electrons of hydrogen is 1, the carbon is 4, while in nitrogen is 5. So let's move on to the triple bond, on how I will illustrate and I will show to form the triple bond. As we say, we put 3 dots in here and also in nitrogen, well, the 2 dots is in here. As you can see, we form now the triple bond. Since we're talking about the octet rule, let us now count if they are in octave. Hydrogen has 2 plus this 6 is equals to 8. Carbon 2 plus this 6 is equals to 8. Since the covalent compound is sharing of electrons. C, sharing with nitrogen, so they have 6. Since we have this 2, by the nitrogen, we add this 6 and 2, their equal is to 8. The chemical compound of HCN is hydrogen cyanide or formaldehyde. Then the chemical formula of hydrogen cyanide is H, C, and N. Hydrogen cyanides and its compound are used for many chemical processes, including fumigation, the case hardening of iron and steel, electroplating, and the concentration of ores. It is colorless, extremely poisonous and flammable liquid. Thank you for listening. I hope you all learning to me. Thank you.
Give an example of triple bond, and this is the chemical formula, and chemical compound is acetylene or ethene. The C2 or carbon 2 and H, hydrogen 2. First, count the valence electron for all atoms. And we need to see the valence electron charge to carbon, and carbon is in the group 14, has 4 valence electron, and hydrogen is from group 1 with 1 valence electron. We need to multiply with 2 because we have carbon 2 and hydrogen 2. Then 4 times 2 is equals to 8 plus 1 times 2 is equals to 2. In C2H2, our total valence electron is 10. Always put outside here, and the electronegative atom is in the center, and that is the atom. And assign 2 electrons into each band, 1, 2, 1, 2. And our total electron is 10. When we count this, 2, 4, 6, we already have 6 electrons, and we need to put another 4 electrons. And then we need to put here inside on the central atom. As we can see here, 2, 4, 6, 8, we have the octet rule, but when we go in this compound, we only have 4 electrons. If the central atom does not have octet, move the electrons to the outside of, to form a double or triple bond. So we need to pull this and we need to put here. And when we count the electrons, 2, 4, 6, 8, 2, 4, 6, it's already 6. And we need to put, disregard these 2 atoms here. And when we count and connect the dots of the Lewis structure, 2, 4, 6, 8, we already have 8, and 2, 4, 6, 8, we already have 8 for both compound, and that is follow the octet rule. And that is composed of 8 electrons, but when we count out 1, 2, 4, 6, 8, 10 electrons. And that is the hydrocarbon or the simplest alkaline. It's odorless, colorless gas, and lower carbons are generally gaseous in nature and used as a fuel and chemical building blocks. That's all for showing the triple bond in acetylene or the chemical formula of C2H2.
Alamin muna natin kung ilan ang electrons ng carbon monoxide. CO, C is a carbon, and O is monoxide. Ang carbon mayroong 4 electrons. Ang monoxide mayroong 6 electrons. At ngayon, ating ipag-add. 4 electrons plus 6 electrons is equal to 10 electrons. At ngayon, atin namang gagawin ang sinasabi nating triple bonding. Magsusulat tayo ng C at O. Ang O ay merong 6 electrons. 1, 2, 3, 4, 5, 6. At ang carbon merong 4 electrons. 1, 2, 3, 4. At ngayon, pwede nating i-move itong 2 electrons dito sa gitna para maging balance. At pwede pa din tayong maglagay ng 2 electrons at pwede tayong mag-move. Move tayo dito sa gitna ulit ng dalawa. And ngayon, nakikita ninyo na meron na tayong triple bond. Yan. Yan. Isa pa. C, O. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 electrons. The triple bond.
How to write the triple in covalent bond or bonding. And now I choose element in metal and non-metal. The elements that I choose is C. C is meaning is carbon. And then H is hydrogen. And then Cl is chloride. And now the equivalent electrons of carbon have 4. The hydrogen have 1, and the chloride have 7. And I put the 2 because I have used it a 2 carbon, and I have put a plus and I can add it. And now first thing I do is 4 times 2 equals 8, plus bring down to 1, plus bring down to 7, and then 8 plus 1 equals 9 plus 7 equals 16. I have 16 electrons, and then I'm going to show how triple bond to happen this element. I'm going to write put a hydrogen one dot because hydrogen have valent electrons, and then the carbon have 4 electrons, and I put it the 4 dot, and then I put a carbon, and I put it the 4 dot because carbon have 4 valent electrons, and then I put it the chlorine have 7 valent electrons. I put it the 7 dots, and I can connect it to hydrogen to carbon and connect it to dot, and then I connect it the chlorine. And now let's count the dot. 1, 2, 4, 6, 8, 10, 12, 14, and 16. And now the naming is the carbon, hydrogen, chlorine. Then I want to naming in binary covalent. Binary covalent naming this is D carbon because they have 2 charges in carbon. D carbon, and the hydrogen and chlorine. Hydrochloride because chlorine have non-metal, and I use it the IDE because non-metal. And this is the naming binary covalent. And that's all. Thank you for watching.
I will show you the example of triple covalent bonding. In this triple covalent bonding, I will use 2 elements. These 2 elements is carbon that have 4 valence electron and chloride or chlorine that has 7 valence electron. So 4 times 2 rather is equals to 8 plus 14. 7 times 2 is equals to 22 valence electron. Para po may pakita kung paano yung triple covalent bonding, susulat ko muna yung symbol. Carbon has symbol letter C and chlorine has symbol letter L. Let's go to bonding. Write the symbol, which is C and C inside and Cl outside. Let's to represent their valence electron, which is 4 and 7. Let's use dots. So 1, 2, 3, 4. 1, 2, 3, 4. As you can see, we connect the dots, which is 6. We 6 dots and I put the valence electrons of chloride, which is 7. Both sides. We connect these two to show you the triple covalent bonding. This 1, 2, 3. These 3 lines represent the triple covalent bonding, which is chlorine to carbon and carbon, both carbon, then carbon and chlorine. It's equals to 8. 1, 2, 3, it's 6, 7, 8. 6, 7, 8. That's why it's equal. This both is equals to number 8. So the chemical or the compound name is, because carbon has 2 and chlorine has 2, we use dicarbon dichloride.
This dicarbon dichloride is their chemical or the compound name. Thank you.
Hello there. Now let's talk about how C2N2, or what we call cyanogen, becomes a triple bond. First, let's find out the electrons of each. First is carbon, which have 4, plus the nitrogen, which have 5, and overall we have 18 valence electrons. Now let's proceed of visualization using Lewis dot structure. So first, carbon inside and nitrogens on the outside. Now let's use the valence electrons to bond the nitrogen and carbon. Now we use 6 valence electrons out of 18, so let's consume the remainings. Let's add up here, and also same here. So we will gather the other electrons to make the elements bonds, and it will have a triple bond. Now let's illustrate it. So in the middle, copy the both sides. Then we will get these 2 dots over of 4 dots to put it in here, same as here in the same side. Let's copy the outside dots. So as we can see, it has a triple bond. It also can be illustrated as like this. So this is the visualization on how the C2N2 or cyanogen becomes a triple bond.